We're going to take a look at hydraulic testing and service in this video. So number one again is understanding how the system's working and understanding what the problem is so that we can accurately troubleshoot and repair the problem with the hydraulic system. Is it a relief valve that's opening? Is the system just not working properly? So some of the simple tests that we can do in the system. So number one is, where's our source of information that we need to get in order to understand how the hydraulic system works? Again, having a schematic is really important in determining where the problem may lie, but again, understanding how the hydraulic system works. So making sure that we have all the information we need in order to troubleshoot the problem properly. So some of the simple things that we want to do first is visual inspection. It could be that we're just doing a visual inspection on the system to correct any problems. Do we have a leak in a cylinder that's creating the problem? Doing a visual inspection of the whole machine and noting any of the issues that we have on the machine so that they can be repaired before the machine goes back into service. If we're taking a look again at the filters, if we're doing a service on the machine, we should be checking the filters, cutting them open to see what kind of debris we have in the filters themselves. And with that, we can also determine any problems that might be coming due in the system. So for instance, if we have steel or brass, where's that coming from so that we can fix that problem before that contamination gets in and works on other components and we have more damage than we had if we just repaired the problem in the first place. So how do we warm up a machine? So again, we want to, before we start doing any testing on a machine, we want to warm that machine up. So we can warm it up by cycling the hydraulic systems and making sure that that warm oil gets through the whole hydraulic system before we do our testing. What type of test equipment? Well, there's all sorts. Number one is, we talked about this earlier, anytime that we have oil leaking past a component, whether it's the pump, relief valve, hydraulic cylinder, it's going to generate heat as that oil is getting pushed through there. So by comparing the oil temperatures of different components, we can quickly determine where that oil is coming from and where it's bypassing. Another thing is a thing called cycle times. Now, in the book of specifications, it will give us a cycle time. For instance, from a bucket, so when it's dumped to curl up, it should give us a certain amount of time to do this. We can also do this with tracks. So we can lift a track up off the floor and we can mark a track and we can do the cycle time on that track to determine if we've got a problem with one of the track motors. So it's a good indication for us to figure out any of the issues that we might have. Now again, we talked about, is the issue with the whole system? Is the whole system really slow? Or is it just one of the circuits that's slow? And again, determining where that problem is and isolate that problem to either a system or a circuit is beneficial for us in repairing that problem. So hydraulic stall tests, again, a couple things we want to be able to do is we want to check to see what our pressures are. So having a flow meter in the system is really important. Checking the pressure of the relief valves. So using a board-on tube, again, we want to check to see what the pressure is in the system to verify that it falls within the specifications in the manual. So putting a pressure gauge in the system and testing the pressure is great, but the other thing we want to be able to do is check the whole system out. So checking to see what type of leakage. Now just checking pressure is going to tell us some things, but we want to make sure that our pump's putting out adequate pressure. So one of the nice things about a lot of the equipment is having a quick connect on the hydraulic system, so we can just plug a gauge in. We don't have to take a fitting off and plug a gauge in. So they're handy to have are these quick test ports. Now let's just take a look at a very simple schematic. Again, we have our reservoir, we have our positive displacement pump, an open center system, returns through our filter back to our tank. Now we want to check the inlet restriction also. It's something that gets overlooked in a hydraulic system. So what can cause problems? Well, let's just say that if our inlet filter is plugged, we're going to have a high inlet restriction on our pump. What's that going to cause to our pump? Well, it's going to cause cavitation. Number one is because the pump's trying to draw more oil in than it can get in there, so it's going to cavitate. So we want to check inlet restriction. So again, we talked about different types of gauges. So we can use a vacuum gauge on that, and that's going to check inlet restriction. We can use a PSI-A gauge, which is, remember, an atmospheric gauge. So that when it's sitting there, it measures 14.7 psi just sitting there because it's a PSI-A gauge. Now on the outlet of the pump, we're going to use a pressure gauge. Now let's just say that our pressure in our system is 2,250 for our relief. We don't want to use a gauge that's 2,250. We want to use one that's higher. Let's just say a 4,000 or 5,000 psi gauge, because we don't want it topping out and run the risk of wrecking the gauge. The other thing we want to do is we want to check the return line restriction. Remember, this is an open center system. There should be no restriction getting back through the filter. If we have back pressure in the system, it's going to create problems in the whole system. So we want to put a pressure gauge on the return side of the system to see what type of pressure we're getting, back pressure we're getting in the system. So we can go in and we can check to see what our pressure should be. Now again, an open center system, we're going to show some pressure because we have resistance within the system in the hoses as the oil is going through, which is not an issue. But we want to also go in and we want to test to see what happens within the system as we, for instance, cycle the controls. So what we can do is we can cycle the controls, raise and lower. Here we're going to raise the hydraulic cylinder, and we can check to see what the relief pressure is when we end up topping out this cylinder. So as it extends fully, once it gets to the end, the oil can't go anywhere. The relief valve is going to open, and we can check to see what the relief pressure is set at, and does it fall within the specifications. We can also go in and we can lower the load and see if it does use the main relief or uses a circuit relief, and see what these open at and compare them again to the specifications. So maximum system pressure again is going to work on the system relief, not a circuit relief, but a system relief, and see what that's set at. Maybe it's too low. So again, we want to know what's going on in the system. So test ports, again, inlet restriction, system pressure. We may have pilot pressure. Maybe our pilot pressure is too low from our pilot pump. So again, understanding and having a schematic and being able to go in and see where the system problem is. Now, we talked in the last video about a closed loop system compared to an open loop system, and again going in and having our test ports to see where the problem might be in a closed loop system. So port number one is, again, it's on the inlet side of a pump, so we're checking for a restriction. Number 2 is, and number 3 are testing the pump pressure to our motor. Now, what are we checking here? Well, we're checking to see if our relief valves are opening too soon. Test 4 is checking our pilot pressure. And again, when we're checking our pilot pressure in this system here, we have a relief valve, so we're checking this relief valve in here. And number 5, we're checking the return flow back through our cooler back into our reservoir. Now, we talked earlier about what's the quick check for a cylinder bypassing. Be very careful when you're using your hands on this, because that cylinder can get extremely hot and we can burn ourselves. So using a temp gun is probably the best way. It's more accurate. We can check different places on the cylinder to see where it's bypassing, whether it's top and bottom. And if we have 2 cylinders on a machine, are they both the same temperature? Because the one that's bypassing is going to be a lot warmer than the one that isn't. And checking it compared to some of the other cylinders. And again, this is why it's really important to warm up that machine before we start testing. Once the whole machine's nice and warm, it's much easier to find a bypassing cylinder. Now, a thing called drift time. So this is where we will lift the boom and extend the cylinders. And what we want to watch for is any of the cylinders drifting. So if a cylinder starts to drift, it's an indication that there is a problem, and it could be in the valve, it could be in the cylinder. Now, after a bit, that cylinder will eventually stop drifting because we'll have equal pressure on both sides. But again, if you take a look at the cylinder, where's the most amount of oil in there? But it's something really to look at, because we don't want our control valves bypassing and allowing that cylinder to drift. Another thing that we talked about is cylinder leakage test. So what we can do on this is we can dead end a cylinder, take off the top line and put it into a bucket and try and extend that cylinder again. And what we'll get is, if it is bypassing, it will leak out that hose. You can't do it with the cylinder that's partially extended, because you're going to get a lot of oil out of there if you try and extend it. So you have to dead end those cylinders in order to do this cylinder leakage test. Now, if we're doing an articulating cylinder, we can put our safety lock in. So here we got a safety lock in, and we can check bypassing cylinders. On an articulating machine, the most amount of wear in that cylinder is going to be in the very middle of both of those cylinders. If we go to the very end, it may not leak. So this is where we want to put our safety lock in and check our cylinders in the middle of the cylinder. Another thing we want to check is case drain. We talked about this earlier. Is if we on our pumps, on our motors, we have leakage that leaks by there. Now we got our case drain drains that oil back to the sump or back to the reservoir. We can pull off that case drain, run the machine, and see what type of leakage we're getting. With that, we can determine if the pump is starting to fail, if we get excessive leakage. Leakage from, for instance, a motor, that oil now isn't being used to drive the machine. So it's wasted energy. So if we're not using it properly, it's just going back to the sump. So we talked about using a flow meter in the system. So what does a flow meter do for us? Well, it does a couple things. So it tells us what the output of the pump is. It tells us what the pressure of the relief valves are, and it tells us what the temperature is. So what we have is we hook this up in series with after the pump, and we have a load control valve. Now, when this is wide open, so anytime we're hooking up a flow meter in the system, we will take and we will open this valve wide open because we don't want any restriction in the system, and we want to see what the pump output is with no restriction on the system. So here we're going to hook it in series. So we're going to disconnect from our system, and we're going to hook our flow meter in. Now again, what we're going to do is we're going to start the machine, we're going to bring it up to the proper RPM, and we're going to see what the output flow of that pump is. Let's just say our pump output is supposed to be 50 gallons a minute. Now that's 50 gallons a minute with no restriction. Now what we want to do is we want to turn our load control valve down. And that was what we're doing, is we're creating internal resistance with inside this flow meter. And as we turn this down, our pressure is going to rise. And what we want to do is we want to bring it up, and we want to see what our flow is at system pressure. So again, let's just say our system pressure is 5,000 psi. Our pump puts out 50 gallons per minute. We want to see at just before relief pressure what our pump is putting out, and that will determine how efficient our pump is. If our pump's only putting out 20 gallons a minute, then we have a problem with internal leakage within the pump. The back pressure in there is causing that oil on the pressure side to return to the intake side, so it's not coming out. What would be a good indication that that's the problem? The pump will be overheating. Now if we hook the flow meter in series like this, again, this works perfectly fine. And again, we can check our pump efficiency doing this way. Is we can throttle this down by increasing the load within the flow meter, and again, this will tell us how efficient our pump is. Now when we're doing, again, different types of pumps, you have to follow manufacturer recommendations for putting the flow meter in. So in a case like this, our flow meter is still in series, but again, this is a closed center system. So what's happening is we're putting a pressure gauge on our pilot line that goes in to control our swash plate angle. And so what we're doing is we're going to see at what point this stops flowing. Again, removing the case drain to see how much oil we're getting out of the case drain will indicate how bad the pump is bypassing. When we take and we install it for testing circuits for, do we have any leakage in a circuit? So again, what happens is we have this set, and we want to have this set just below the main relief, because we don't want the main relief opening. We want to check to see what type of leakage we're getting past the cylinder. So what we're going to do is we're going to top out the cylinder, and when we do that, all the oil has to go through this here. Now let's just say we have done our testing and our pump puts out 40 gallons a minute at 5,000 psi. If we set this just below the setting and this pump reads 30 gallons a minute, where's that other 10 gallons going? Well, it has to be leaking past the cylinder and then returning to the sump. So what we're doing is we already know what our pump output is. We want to see when we extend a cylinder completely how much flow is going through here, because this relief valve is an opening, and any differential in flow has to be bypassing a cylinder. Now when we take a look, and we looked at this earlier, when we go in and we do our flow tests. So again, looking at the specifications. So for a John Deere 450C loader specifications, our hydraulic pump puts out 32 gallons per minute at 2,250 psi at 2,500 RPM, and the system temperature is 66 degrees, or 6 degrees Celsius. Now, what we have in all of these, if we take a look at our pump at zero pressure, it puts out 32 gallons per minute. But as you see, as we start putting a load on the flow meter, what happens to our flow? Well, it drops. Now, again, our pressure is 2250 psi for our relief pressure, and of course at 2250 our flow drops to 28.1. Now again, it's dropping 4 gallons per minute, and again it will tell you what the efficiency is. So what we can do is we can look at each of these circuits and see if they're operating properly. So let's take a look at the boom circuit. So looking down here at the boom circuit, the relief pressure for serial number 206.828 up to that serial number is 2,250. Anything above that is 3,100. So with this, we know what our serial number is, and our serial number is 207931. So our serial number is after that, so our relief setting should be 3,100. So going through and looking at our serial number and what our flow rate should be, we can see that our relief setting is for our boom circuit is 2000 psi. What are we supposed to be at? Our boom circuit lift is supposed to be 3,100. So it's cutting out early. If we take a look at our bucket circuit, again going down to what our specifications are, our bucket circuit is 2,250 on the piston end. On the rod end it's 1,500. And when we take a look at these, we can see that our bucket clamp, open and closed, are both at 1,000. So going through and seeing what's happening in the circuit will determine what's the problem in the system. So is it a relief valve that's just set too low, or is it a relief valve that's failed? So we take a look at our ripper. Again, you can tell right away that when we go to raise it, it's open right away. So we have a definite issue here. The relief valve isn't even working, so it's just dumping all the oil back into the reservoir. So it's a good indication where we can start looking. So again, understand how the system works so that we can troubleshoot it better. Visual inspections to see where our leaks are. You know, washing the machine. So again, do a visual inspection of the machine, wash the machine, run it again so we can determine where that oil is leaking from. Do an operational test, whether it's cycle times or putting a flow meter on, to check to see how our system is failing. And again, once we've determined what has caused the problem, then we can get in and take that component apart to see if it has failed. Now, a lot of the systems now, we just replace the component. We've determined that it's the pump that's causing the problem. We're going to take the pump off, send it out to be rebuilt, or we get a reman pump.